Welcome, Pythonistas and Pythoneers. Now, the one, the one more most useful Python class is Boolean, which is free defined true and false objects that are essentially just the integers 1 and 0 with custom display logic. Now, Python today has an explicit Boolean data type called bool with the values true and false available as new pre-assigned built-in names. Bool accomplishes this by redefining string str and repr string formats for its two objects. And the most intriguing fact is that none also an object commonly used to initialize names as an objects. And last but not least, the type object returned by the built-in function type is also an object that gives the type of another object. So now let's do some hands-on on booleans and related objects. So let's begin here. I call it as other objects. We'll begin with booleans. We'll just execute type of true. It is boolean. That's what I'm talking about. The true and false are itself are objects thereof boolean object. So out of which using this boolean objects we can do some operations. The one of the most useful inbuilt function is instance. So what we do with that is instance. This is the construction of is instance inbuilt function. This is how we call it. We call initially we'll begin with an object and then we'll add a class or tuple, and this is default. So it returns whether an object is an instance of that class or of a subclass thereof. Let's see an example. I have given true as an object and I am asking whether true is an int type of class or not. Let's see. It is true. That means true is also int type because inherently it is true and false are nothing but 0 and 1. So that's the reason. Now is instance whether 4 is int or not. Obviously 4 is int. Is instance 4.5 is int or not? I hope it's not. Let's see. Yes, it is not. It's false. And similarly, true double equals to 1. Let's check. Yes, true inherently is 1. False is inherently 0. Hence, proved. Whatever I have been claiming, that has been proved here. Okay. So now the second thing is true or false. 1 or 0. Obviously, we'll get true only. And when I say true plus 4, we get 5 because inherently true is 1. So that's why I have included true and false, the boolean object inside our numeric type. And then we have a none. none type object. So I have attached a reference variable to none type object, and let's see what is the type of object. It's none. And then we can actually repeat this none 100 times using a repetition operator. So this is how, and it had made a list because we have wrapped that none inside a list literal. So what it tells us is none is also like an any other object. That's what you have to note down here. So in addition to this, we will see some bonus code, because as a gift to you, because you have come too long. You have come so far. You just followed me and you have come so far. That's why I just want to give you this gift, that is a bonus code. Okay, let's begin with the decimal numbers, because in we have seen in numeral types, we have seen int, float, and complex. So now we will see booleans and we will see decimals, how we can we deal with decimals. So I have told you earlier, in earlier videos, that a module file can be imported using its name. So somebody has written decimal.py and stored inside our Python directory. When I import and mentioned name of the file without extension, the Python gives you an access to use the namespace of that module. So now once I entered inside that module, so whatever functions, attributes it has, I can use it. So for that we have to use that attribute reference. So this is the module name dot, and then a function or method, specifically that method which is written inside that module file. You just call it and we'll get it. So it is, what we got is a decimal object, and then we can do as usual, we can do arithmetic operations with this. So this is 3.141 is not int, not float, this is a decimal object. If you add 1 to it, you get decimal object itself again. And after that what we'll do is we will explore more methods in that decimal module. So in that we have get context and dot prec. So I have taken two decimal numbers. This is 1 and this is another decimal number, 1 and 3. When I do 1 divided by 3, what I got is a decimal number of 0.33. So next we will move on to fractions module. So fractions module is as similar to the or decimal module, but here the name of the module file is fractions. So you use that name to call and access the namespace of that module. So this is a different way of calling. So here I'm using from fractions import a specific method or file in it. So a fraction of 2 comma 3 will give you a fraction object. So these objects are basically not core types, but they have written with additional modules to make this object, either it is decimal or fraction. You have to import a module, then only you can create an object. So it is nothing but they have written some classes and then using those classes we are able to create those objects. And then when I do f, the fraction number 2 by 3 plus 1, what I get is 5, fraction of 5 comma 3. When I do addition with the another fraction number, what I get is another fraction number. This is how we handle fractions using fraction object from fraction module. Now we will also look into math module. So again we will import the math file, and then out of which math has these attributes in it. Pi is one attribute, e is another attribute. We will call both those using this dot. So math dot pi and then math dot e will give you the values. These are attributes. And then similarly we can do some more calculations. We can use sine function, cosine function, tangent, angles to calculate. So this is another way to do. So this is the value we got, and we can calculate the square root. So here I have calculated square root. Square root is a method of math, so that's the reason math dot square root of 144 and then math dot square root of 2. Now square root of 144 is 12 and square root of 2 is 1.414 and 4. So this is how we can use the methods in the module. And then we have another function, that is floor. When I use another method, floor, when I use floor method, it will round it off to the lower side. Same applies to the negative number, it will round it off to the lower side. When I use truncation, that also does the same. So till now we have seen different modules, and now we will look into some of the inbuilt functions that are available to do some mathematical operation. So the first one is power of 2 power 2 comma 4. This is inbuilt function. You just use power, and 2 comma 4 is what you want to know the exponentiation. So see, it is 2 power 4, that's 16. This is another way of doing the same exponentiation. And we have absolute of minus 42. So this will give you, this will convert into a positive number. And another function what we have is a summation, the sum. It will give you sum of the tuple that we have given. So this is 42, it has become positive, and then 10, 1 plus 2 plus 3 plus 4, the summation is positive. And then what we have is what else we have is a min function and then max function. These are inbuilt function. Min function gives you the minimum number out of the numbers that we have given, the arguments that we have given, and max gives the maximum out of which out of the arguments that we have given. Let's check it out. Let's check it out. So 3 comma 56. Nice. So finally, before closing it, we will look into random module. We'll look into a random module. So here in a random module, as it is, we will import the namespace, and we will import the namespace using name of the file. So random is the name of the file or name of the module, and once I get an access to that file, I can use the attributes and methods that that module consists of. So random is the module name, and then another random is the method inside that. It gives a random numbers from 0 to 1. These are all floating point numbers. See, when I type now 0.34, 0.64, 0.96, this is used to generate random numbers. And then we have random dot randint. Here we can give start and numbers, and we'll get the random int in between them. So first 3 we got, 9 we got, and 1 we got. So this is how we can use this methods from random module. And then we have random choice. If you have a list of names, if you want to choose it randomly, so you can use that choice method from the random module. So now it has chosen coconut, now again coconut, banana, now banana again, it's apple now. So this is how it will be useful. I would like to request you to explore more, just practice more on these modules. So with this we are done with module 2. So now let us wrap the module 2. Module 2 is nothing but Python core data type, if you remember. I hope you are following me. Python core objects. After we'll close it off with a brief summary of the whole module. Okay. The point main point to note here is that everything in Python system is an object type and may be processed by your Python program. For instance, you can pass a class to a function, assign it to a variable, stuff it in a list or dictionary, and so on. So whatever it may be, everything is an object. Everything in Python is an object. So further, Python core data types or core objects can be divided into the following categories based on the nature of the objects. The first one is numbers. Numbers, which can be subdivided into 4 subcategories. Which can be subdivided into 4 subcategories. First one is integer type. Integer type which does not have any decimal point, under which we get int object, and boolean object, and the second object is float float object, which consists of decimal points, and the third object is complex number object, which consists of real part and imaginary part, which in turn are float objects, and the precision decimal point object to be imported, this decimal object to be imported using the decimal module. And finally, to make numbers in fraction form, we must import fraction module to generate these fraction type objects using in numbers. And the second category is collections. The second category is collection. You can clearly see there it is collections. So here we put all characters together and store it in a container. Depends upon the nature of container, collections are subdivided into different type of objects. So we will begin with sequences first. We'll begin with sequences. Here you can see We'll begin with sequences. Sequences are the type of containers where items are arranged in an order from left to right. Though it is ordered collection of some sequence objects are mutable, some are not. Though these are ordered collections, some sequence objects are mutable, some are not. Let's see which one is mutable and which one is not. So first thing is, in sequences, immutable sequences are string, tuple, bytes, and whereas mutable sequences which can be changed in place are list, byte array. Now the second type of container to collect items is mapping. So where the collection of items based on key value pair, not based on left to right position like sequences. Okay. Now each item will be mapped to certain key. Each value will be mapped to certain key. This type of object is known as dictionary, which is also mutable. Next, the final type of container to collect items is as sets. Here it is, sets. These containers takes only unique items which are unordered but mutable. Set and frozen sets are two objects come under this category, which actually a frozen set is used to get an immutable. This frozen set is used to get an immutable set because sets are fundamentally, inherently, they are mutable. Then what we will look is the third category is callables. Callables, in which we will find function object, generator object which can be generated with yield, and then class object which is the blueprint to create many objects, and even our method also known as type specific functions are all the objects that comes under callable category. These are all comes under callable function, generator, class, method. These are all comes under callable category. In others, in other category, we can see module. In later sessions, we will deep dive into that. Instance and file object. File object, just it's file object we have seen already, and a non-object we have discussed just now, and a view object we will discuss later. And finally we have internals. We have discussed by and large type object, code frame, and tracebacks. So in a nutshell, objects share operations according to their category. For instance, strings, lists, and tuples all share sequence operations such as concatenation, length, and indexing. 2. Only mutable objects such as lists, dictionaries, and sets may be changed in place. You cannot change numbers or strings or tuples in place because they are immutable. And third, Sets are something like the keys of a value-less dictionary, but they don't map to values and are not ordered. So sets are neither a mapping nor a sequence type. And frozen set is an immutable variant of set. Just I have told you. And the fourth point is files export only methods. So mutability doesn't really apply to them. So after completing this a complete module, that's Python core data types, the conclusion is Python is all about objects. I will repeat this again. Python is all about objects. I hope you enjoyed this session, and then you just keep you just keep following my videos and keep watching it, keep subscribing it, and keep liking it, and keep sharing it to the maximum people, so that everybody can get benefit out of it. Thanks, and see you again in another videos with the more exciting stuff. Thanks.